Hi everyone, my name is Kat Hartwell, and today I'm going to talk to you about dibromochloropropane, also known as DBCP, and the health effects that this chemical had on workers at the Occidental Chemical Company in Lathrop, California. I'll also explain how this case had broader consequences on worker protection and the public understanding of toxic chemical exposure in the U.S. Here is the table of contents, which outlines the figures and topics to be discussed. I'll start by providing the purpose and objectives of this presentation. Then I will provide some background information on the growth of DBCP production in the United States between 1960 and 1975, followed by an examination of how the chemical was being used across the country in 1977 when the Lathrop case came to light. I will then show you a graphic of a study of workers at the Occidental Chemical Company that visualizes the relationship between the duration of exposure to DBCP and the sperm counts of workers. Following that graphic, we will see findings presented in 1978 that reveal the results of a study on the effects of DBCP exposure on rodents. We will end with a map that illuminates the countries where DBCP was exported and used following regulations and restrictions passed in the United States. Then I'll present a summary of the findings introduced in this video. The objective of the next few slides is to provide an overview of the trajectory of DBCP production and use in the United States. Dibromochloropropane, which I will refer to as DBCP from here on, is a chemical compound that can be used as a soil fumigant pesticide to prevent and eliminate nematodes, small parasitic worms that feed on the roots of fruit and vegetable plants. DBCP was first produced in the U.S. for agricultural use in 1955 and became widely popular in the 60s and 70s because it was effective in removing nematodes but did not damage the plant in the process. In 1977, a worker at Occidental Chemical Company in Lathrop complained about fertility issues he was having to coworkers during a lunch break. His colleagues began comparing their own struggles with fertility and worried that something might be wrong. A few of these workers took the issue to their union leaders, who then persuaded 7 employees from OCC to undergo fertility tests. The results of these initial tests revealed all 7 workers to have 0 sperm counts or sperm counts so low that the men were deemed sterile. This revelation led the union to reach out to the U.S. National Institute of Occupational Safety and Health, or NIOSH, to conduct a health hazard evaluation. Additional research on DBCP was conducted both at the Occidental Chemical Company and other companies that produce the chemical across the U.S. Later that year, researchers confirmed that DBCP can cause azospermia, or a complete absence of sperm, as well as oligospermia, which is a low sperm count, in males exposed to the chemical at certain threshold levels. Let's take a step back and look at the production patterns of DBCP leading up to the events at Lathrop. This first figure here illustrates how the production of DBCP grew exponentially in the U.S. between 1960 and 1975, with 5 times the amount of the chemical produced in 1975 as was made in 1960. Figure 2 conveys the widespread usage of DBCP throughout the agriculture industry in 1977, which is also the year that the fertility impacts of DBCP in the Lathrop workers was discovered. As you can see in this table, the chemical compound was being used to treat a wide range of crops. 33 million pounds of DBCP was used in 1977, and 2.3 million acres of land treated with the pesticide. This is 8 million more pounds than just 2 years before. The percent of total crops treated with DBCP in 1977 varied, with some plants more dependent on the pesticide. Take a moment to look at the table. As you can see here, plums had the highest percentage of DBCP usage, with 69.9% of the total annual crop yield having been treated with the chemical. Figure 3 illustrates the results from one of the studies conducted on a sample of workers at Occidental Chemical Company in Lathrop in 1977, after workers brought forth concerns about fertility issues to their union leaders. This study examined the relationship between the duration of DBCP exposure and sperm levels in workers. Please take a moment to look at the table and absorb this data. 88% of the workers sampled with no exposure to DBCP had normal sperm counts. But as exposure time increases, the percentage of workers reporting normal sperm counts decreases, and the percent of workers with low sperm counts increases. This trend is most dramatic for workers with more than 2 years of DBCP exposure. This table illustrates a clear increase in the incidence of abnormally low sperm count when exposure to DBCP increases. In response to the Lathrop studies on workers from the Occidental Chemical Company, a number of other studies were conducted on the effects of DBCP. In 1978, the National Cancer Institute published the results of their research into the health effects of DBCP on rodents, following years of testing. Figure 4 encapsulates a snapshot of some of their findings. You can see in the upper pie charts that a majority of both groups of male rats exposed to DBCP experienced testicular atrophy, which can reduce or diminish spermatogenesis, which is the process of producing sperm. 76% of rodents exposed to the lower DBCP dose experienced testicular atrophy, while 95.9% of rats exposed to higher dosages experienced testicular atrophy. Additionally, the carcinogenic potential of DBCP was also established in this study. You can see in the lower pie charts that 94% of male rats and 76% of female rats in the lowest exposure sample developed gastric carcinomas, or stomach cancer. In the aftermath of this incident, the U.S. implemented controls to protect workers from DBCP exposure and banned the chemical from agricultural use in 1979. However, the chemical was still distributed, marketed, and sprayed in the Philippines, Latin America, India, and parts of Africa. Figure 5 shows a map of countries where DBCP was exported. In summary, DBCP has been determined to be a human reproductive toxicant that can lead to azoospermia and oligospermia. Exposure occurs through dermal and respiratory pathways, and the duration of exposure increases the risk of testicular toxicity. Studies conducted in the 1970s on rodents also demonstrated an association between gastric carcinomas and DBCP exposure. The events in Lathrop, California, became the first widely known episode of worker infertility that was related to occupational exposure of DBCP. After being banned in the U.S., DBCP was exported and used in several other countries. A number of class action suits have been filed against American pesticide companies on behalf of workers suffering from sterility related to DBCP exposure. The Lathrop, California case prompted further research around the globe into the effects of a variety of chemical exposures and the possibility of environmentally induced infertility. On a side note, Occidental Petroleum Corporation is the parent company of both Occidental Chemical Company and Hooker Chemicals and Plastics, who is responsible for the environmental disaster at Love Canal in New York State in 1976. This is the references slide. Thank you all for listening, and I hope you enjoyed this presentation.